Hey, welcome to Build&AI. I'm Nia, your AI learning guide. Let's get into it.
Hey everyone, and welcome to this explainer. Today, we're diving into something literally every single one of us builds, but let's be honest, surprisingly few of us get completely right. Forms. We're going way beyond the basics today. We're going to walk through the ultimate architectural guide to building reliable, type-safe, and accessible React forms that absolutely will not break at scale. We're moving past just making things work on the happy path, and instead, we're focusing on creating bulletproof data gateways. So, here's our roadmap for today. We'll start with why web forms break, then compare controlled versus uncontrolled inputs. After that, we'll look at adding TypeScript safety, smart validation strategies, async submit and feedback, and finally wrap up with accessibility and pattern reusability. All right, let's jump right into part one, why web forms break. I really want you to think about this for a second. Have you ever filled out a complex online form? Carefully typed in all your information, clicked submit, and then watched all your data just vanish into thin air? No way, right? Or maybe you're on the developer side, staring at a console that's completely clear of errors, yet the database is somehow missing records. We have all been there. It is a deeply frustrating experience for users and an absolute debugging nightmare for us developers. These problems usually show up the second a form leaves its happy, ideal path. You encounter unpredictable user inputs, unexpected double clicks that trigger race conditions, or maybe a dropped network connection right in the middle of a post request. When our architecture doesn't account for these edge cases, well, data drops. Relying purely on native browser behavior, basically leaving value management up to the DOM, exposes our apps to untraceable bugs. If an application doesn't explicitly control what happens when a field is left empty or when a user submits multiple times in a row, the experience degrades so fast. Think about the complexity of trying to clear fields, show dynamic error messages, or pre-fill data based on API calls when the DOM is the one calling the shots. It becomes incredibly error-prone. This leads to those notorious silent failures, where the UI looks totally fine, but the underlying data model is completely broken. We really need to move from forms that just work during local testing to forms that are genuinely reliable in production, under heavy, unpredictable use. Moving right along to section 2, controlled versus uncontrolled inputs. The core difference here really boils down to how we manage data architecture. Think about uncontrolled inputs. The DOM manages its own internal value, totally disconnected from your app's JavaScript logic. This creates a really dangerous split-brain scenario. The DOM thinks the value is one thing, but your React component might think it's another. Or worse, have no idea it even exists until the form is submitted. Now compare that to controlled inputs. Here, React state is the single, undisputed source of truth. I love using the mirror analogy for this. Think of React state as the official, audited record of your data. The screen? Well, the screen is merely a dumb mirror reflecting that exact record. When a user types, they aren't directly mutating the input field on the screen. They're firing off a request to update the official record in React. Understanding how data flows in this controlled model is absolutely crucial. It's a continuous, strictly one-directional loop. The instant a user types a key, an on-change event fires, capturing that text. Our handler intercepts that event, reads the value, and updates the React state. React then triggers a re-render, and finally, the input displays that newly updated value pulled directly from state. This rapid back-and-forth flow guarantees your UI and your underlying data never, ever fall out of sync. And this matters immensely because it means even if a user mashes the keyboard, pastes a massive block of text, or tries to inject a script, React intercepts that action first. You have total control to sanitize, format, or reject that input before it ever officially becomes part of your application state. Okay, let's look at section 3, adding TypeScript safety. When we connect our form architecture to TypeScript, we primarily deal with two distinct event types. A change event fires whenever a user modifies an input, a select dropdown, or a text area. A form event, on the other hand, represents the entire form element and captures the full submission action. Keeping these two clearly defined and separate is just vital for scale. By specifically typing a change event to an HTML input element versus an HTML text area element, you prevent yourself from accidentally calling properties that don't actually exist on specific DOM nodes. If you mix these up or fail to type your handlers correctly, you lose all the powerful autocomplete and compiler assistance that TypeScript offers. You might accidentally try to read a specific text value off a form submission event, which will absolutely cause a runtime crash. Silencing the compiler with any hides bugs until runtime. I want to emphasize this because it is a massive architectural anti-pattern. If you type an event handler's parameter as any, or just leave it implicitly untyped, you're deliberately removing every single safety net TypeScript offers. Every warning you bypass this way mutates into a bug that only rears its head when real users are interacting with your production application. For example, typing your payload as any might let you accidentally pass an entire synthetic event object instead of a sanitized value string directly into your API call. The compiler stays quiet, but the moment a user hits submit, your server throws a 500 internal error because it doesn't know how to parse a massive JavaScript event object. Seriously? Don't bypass the compiler. Let it do the heavy lifting for you. Next up, Section 4, Smart Validation Strategies. Validation architecture is fundamentally about timing and psychology. Think about it. When exactly should we tell a user they made a mistake? Validating on keystroke, running a full, aggressive validation cycle on every single keystroke, is a major anti-pattern. It distracts users and severely punishes them before they've even finished their thought. Imagine being told your email format is invalid when you've literally only managed to type your first name. It's incredibly hostile UX. Validating on submit, however, is a much friendlier default. It lets the user fill out the form in peace and surfaces the exact right feedback at the exact right moment. Now, for more complex multi-page forms, an excellent middle ground is validating on blur, meaning we run our checks the exact moment the user tabs away from a specific field. But for standard data entry, waiting for the submit action ensures you aren't interrupting the user's flow. Let's move to Section 5, Async, Submit, and Feedback. Let's dissect the most chaotic moment in any form's lifecycle, the critical submit sequence. At 0 milliseconds, the user clicks submit, and our code immediately validates the localized state data. If everything passes at exactly 50 milliseconds, we set an isSubmitting state to true. This gap is absolutely crucial. This instantly disables the submit button, both visually and functionally. Why does this matter? Well, because if you don't handle this state, a user experiencing network lag will frantically double or triple click that button. Without that isSubmitting lock, you've just fired off 3 identical post requests, potentially double charging a customer's credit card or creating duplicate database records. Yikes! At 100 milliseconds, our async request fires off safely. Finally, at 800 milliseconds, when the request successfully resolves, we turn off the loading state, clear the form, and display a success message. If the network request had failed, we'd intentionally keep their data intact on the screen and render a clear error message. This tightly orchestrated flow completely eliminates user anxiety and preserves data integrity. And finally, Section 6, Accessibility and Pattern Reusability. An accessible form isn't just one that looks pretty on a monitor. It has to communicate its state perfectly to screen reading software. We establish this baseline by linking our inputs and labels using the h4m attribute. But validation is where accessibility often fails. When a field fails our validation logic, we dynamically set the aria-invalid attribute to true. This explicitly signals the broken state to the browser. Crucially, we then use aria-describedby to link the specific dynamic error message directly to the input that caused it. This technical implementation creates a profound human result. Without aria-describedby, a visually impaired user just hears their screen reader say invalid data, with absolutely no context on what they did wrong. By linking the elements, the screen reader specifically announces something like, password input invalid, must contain at least 8 characters. They instantly know exactly what went wrong and exactly where to fix it. That is a real game changer. To guarantee this level of robust architecture, I want to challenge you. Next time you're about to merge a pull request containing a new form, run it through this practical manual QA checklist. First, submit a completely empty form to verify that your validation errors correctly appear on every single required field. Second, intentionally force a server submission failure and verify that the user's entered data stays completely visible. Never wipe a user's hard work just because your API timed out. Third, visually verify that the submit button fully disables during the asynchronous looting state to prevent those race conditions we just talked about. And lastly, confirm that the input fields clear out only when the submission returns a 200 OK success status. The true beauty of this architecture is how effortlessly it scales across an entire enterprise application. We started today by conceptualizing a simple task form with just a title and description. But when you build with this controlled methodology, moving to a mission-critical login form doesn't require reinventing the wheel. You simply swap out the state fields for email and password, and update your validation focus to check regex formats and minimum string lengths. The whole shebang, the core architectural flow, the strictly controlled React state, the strongly typed TypeScript handlers, the smart validation timing, and the async submit locking remains exactly the same. It transfers effortlessly from a simple contact widget to a massive, multi-step financial checkout flow. Forms are the primary gateway for real user data in web applications. Managing them with explicit React state, strict TypeScript definitions, and thoughtful accessibility completely transforms the user experience from fragile to bulletproof. You've now seen the architectural blueprint for eliminating silent bugs, race conditions, and user frustration at scale. So take a moment to reflect on the codebases you're currently working in. How will you refactor your next form to be completely controlled and accessible? Thank you so much for joining me on this explainer. I really hope you take these advanced patterns and use them to build some incredibly reliable, world-class applications.
And that's a wrap for today. If this lesson was helpful, go ahead and hit that subscribe button so you never miss a new episode. We drop 3 new lessons every single week, all designed to help you learn, build, and launch with AI. Share this with someone who's on the same journey, and I will see you in the next one.